Hello everyone, welcome to my channel. Today we are going to discuss convolutional neural network. Before jumping to the major coding section and implementation part, first let's understand why this CNN is a hot cake. It's a biological model. It's designed based on how human brain actually identifying the images. It's work over mathematical matrix models. So the CNN deep learning was actually a deep neural network in which convolutional filters pass along an input matrix. So basically whenever we pass an image to a computer system, it's read that image as a matrix. Say you are passing 400 by 400 resolution image, the system generate 400 cross 400 into 3 matrix. That 3 refers as a RGB color. Now let's understand, for any CNN network we required a convolution filter. The CNN filter looks like a matrix with 0 and 1. As I am sharing now, say we have an image of 5 cross 5 matrix and we have a convolutional filter with 2 cross 2 matrix. So for each convolution process or operations involved with this 2 cross 2 matrix, it slices the 5 cross 5 matrix in 2 cross 2 and perform the operations. In the right upper corner, I am sharing that operation using 3 cross 3 convolution filter. So for 2 cross 2, we have the slice of the 5 cross 5 image is 128, 97, 35 and 22. Now multiplying with 2 cross 2 filter, it's become 128, 0, 0, 22 and the overall value is become 150. For better understanding, I am showing the 5 cross 5 matrix and the convolution filter in left side lower corner area. Now we have a car input image. This input image was passing through bunch of convolutional layers. It's take a patch from input image and apply convolution filters over the patch. Now that results or that process data goes through some pooling layers. Pooling layers are basically a non-linear downgraded layer, and this process was going on one by one. Okay, so we have this kind of set like convolutional layer and pooling layer in a bunch of set. In the end we have a fully connected layer. This fully connected layer get a top 5 or top 10 best matches. It's actually using some probability distributions, for example softmax, SVM layers, and we are taking the maximum matching as a output. Say for this case, this layer is giving us 3 outputs like it's a car with 90% accuracy, it's a two-wheeler with 10%, and it's a cycle with say 1 or 2%. So maximum is going with car, so it's actually predict the car properly. Most of the cases for design this kind of deep neural network, we are going with PyTorch or TensorFlow. So I am planning with going with TensorFlow. Now let's jump into the implementation portion. Now we are going to discuss about the code. I am already write down my code for time saving. So we have a data folder which contains the training and test data. In each and every folder we have 2 folders which contain that cats and dogs image that we are going to identify through CNN. As I am preferring using Anaconda, now I am switching to my deep learning environment and running the Jupyter notebook. So now we are discussing about the code. Uh, I am using TensorFlow as I previously mentioned. So here I am using tf.compat.v1 as tf is actually change the global behavior of TensorFlow 2.2 to TensorFlow 1. I am switching this because somehow I am facing some issue with my GPU, and after studying lot I get that solution for it's really helpful for running CNN models. Along with this, for confirmation, I am doing tf.disable v2 behaviors. Now, in the second portion, we are restricted TensorFlow to only use GPU. Now, we are actually importing that libraries like dense, convolutional 2D, flatten, dropout, pooling, and so and so. Here I am actually reading the data. So after all the process, it's showing that my overall training image is 40 and total validation image is 20. Along with that, I can say that my cats and dog training image are 20 and 20 and validation image are 10 by 10. So I am taking that batch size is 5, epoch size 10, and image height and weight at 150. Now here we are actually generating tensor from images. For that I am using image data generator. This image data generator actually generate the tensor data with real-time data argument. As I previously mentioned that the images are stored as a matrix, here I am trying to show you the fourth image matrix. Now we are using sequential. It's a group of stack of layers. It's provide training and interface feature on a model. Inside this we are using conv2d. Conv2d is actually 2D convolution layer. This layer creates convolutional kernel, and that is convolved with the layer of input to produce a tensor of output. Now next we are using max pooling operation for 2D spatial data. It's actually downsample the image reference or input references. Now we are using flatten. Flatten is the flat the input. It doesn't affect on the batch size. It's actually added an extra dimension. Next we are using dense. It's actually densely connected neural network, and for activation function we are using ReLU, and it's written the max terms of 0 and input tensor. So now I am running that model. Our model build is complete and it's run for only 10 epochs. As I set the epoch size is equal to 10. Now there is the accuracy graph I am sharing. So it's almost done. So for the code reference you can go through my GitHub link. I am sharing the link below in the description. If you like this video, please press the like button and subscribe my channel. I am continuously trying to share detailed deep learning techniques and knowledges in this channel, and along with some design pattern and other implementations also. So please like and subscribe.